Morning, everyone. Just syncing the audio. Good lord. I expect that to be reset at some point. I expect that to be reset at some point because normally if the audio lag is a full 2 seconds, then that's deemed unacceptable and they'll reset the stream at some point and we'll get a better audio lag, although shouldn't make much difference according to you. But anyway, hello? Hello, everybody. I finally got the new modem, and it's installed and everything, so hypothetically speaking, we shouldn't see any more interruptions in the stream today, which will be good and nice, and hopefully that's the case. So this is kind of a bit of a systems test at the same time as being a lecture, but, you know. I'd like to apologize for all of the stream interruptions that we've been having over the last few weeks. It's been mighty unprofessional of me to be having these issues. I have been trying to address these issues as quickly as humanly possible, but, you know, it takes time to do anything, especially with this damn virus going on. But anyway, yes, indeed. So why don't we start the day off by soliciting general questions from the audience? Do you guys have any questions for me this morning pertaining to anything? Oh, and by the way, the light. I usually use my desk lamp as like a light to light up my face so I don't look like a shadow creature. But the bulb in my desk light also went. It's a halogen one, so I can't just, you know, run out and get a new one. It's like, oh, can I just have the equipment keep together for like 3 weeks? Yeah, I also hope that the ghost didn't move into the new modem. That would be terrible. The ghost of Sean Connery. Oh, so you thought you could get rid of me just by getting a new modem? Well, we'll see how that turns out for ya. That's like, I thought that was Sean Connery, but it turned out being, what's his face from the IT crowd, mixed, but just a little gruffer. Oh, what's his name? What's the character's name? It's Moss and Roy. Roy, the Irish guy. Anyway, yeah. Well, doesn't seem like anybody has any questions, so I guess we'll just we'll get started with the lecture material, and, you know, once we have started with that, probably some people will have some questions, so, yep. Doop, doop, doop. How are you guys doing? How are you guys feeling? Hopefully you guys are feeling good. Will the exam have a reasonable number of test cases provided for each question? Well, it sort of depends. It depends on what you consider reasonable. Reasonable is a subjective standard for measurement, so what's reasonable to me might not be reasonable to you. Let's put it this way. There is a conscious effort being made to ensure that there are more visible test cases with the exam than there was with the test. So hopefully that answers your question. But I'm not going to comment on whether it's reasonable or not, because that's kind of like, I would have to know precisely what you meant by reasonable. Tess says you're... Oh, I'm sorry, Tess. Don't worry. The term's almost over. Christmas is coming. Just keep going, man. Just keep slugging. We can do this. I'm ready to dedicate my entire Thursday to doing comp sci. Good, because that's the exam day, and I'm happy that you can dedicate that whole day to doing the exam. I would recommend. I don't think it's going to take the whole day to do. However, you may want to have the whole day available to work on it. Also, I find after writing the exam, it's good to have at least, a block of a few hours to come down off of it, There'll be negative test cases. We have to write several. Yes, no, although you do raise a good point, Paul, that in the absence of test cases you consider to be adequate, it is always possible for you to create your own test cases. In some, that's kind of the implicit expectation, is that if you don't find the test cases to be adequate, that you design your own and run them. You do what you feel you need to do to make sure your code is good. Is this the day we bring about the AI singularity? No, but it would be nice if we could stop people attempting DOS attacks on Mark's server. Apparently over the weekend he had a DOS attack on his server, which hypothetically would be somebody in this course. Apparently in 1JC3, Dr. Farmer talks about what a DOS attack is and how one might go about it. Sort of in the same vein that we talk about SQL injection attacks. If it needs to be said, please don't try to DOS the servers that we're using to distribute this course. Please. If we catch you, we will prosecute under the Student Code of Conduct. And with normal DOS attacks, it's not like if an unsophisticated attack is really easy to trace. So I would recommend not doing that anymore. Scott says, I think we should have an unreasonable amount, but it's unreasonably high. Well, I can guarantee you for the one question there's an unreasonable number of test cases, but that's as much as I'm going to say about it. I heard the test is long from the TA and it took him 3 hours. Does that mean we're literally going to take the whole time? Is this Mark that you're hearing this from? Also, can we know how many questions there are, including bonus? Nope, you'll just have to worry. You'll just have to worry about that until the test happens. I'm not going to reveal the number of questions, the amount those questions are worth, the percentage of the test that is comprised of bonus marks, or any related miscellany. You're just gonna have to buckle up and wait. If any TA has written the test, if they have, then I haven't heard about it. So, But yeah. Hello? Testing? Testing? Testing, testing. Testing, testing. Testing, testing. Testing, testing. Test, 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 test. Looks like we've got some reconnection, as long as we can keep that kilobytes per second up. Okay, so looking at that, well, the stream cut out around 10:40, and it is now 10:43, so 3 minutes. They've cut down the amount of time that they've cut down the amount of time that we're down when we're down, but I'm not sure how much of that is, I'm not sure how much of that is the new modem and how much of that is that I've reconfigured OBS to be more militant about trying to re-establish the connection. Although I think maybe it's helped. Anyway, okay. Let's, yeah. Okay. So the problem is still happening. Yay. Great. So the new modem didn't fix the problem. Ugh. Will you do the fandango? I can't sing on stream because apparently people are getting copystriked for like singing songs on stream now, which is kind of funny. I mean, I'm not monetized to begin with, but like I had this interesting situation last semester, I think it was, where they just killed my stream outright, sent me a copy violation notice, and like I hadn't done anything. What had happened was my wife was watching TV in the other room, really quiet, and like not TV. It was like during the beginning bits of the pandemic, and she was watching CBC News because, you know, watching CBC's news is a thing that you do during a pandemic and at no other time. And the yeah, they just killed my stream like that, and I was very. Didn't I say though that they probably were gonna disconnect me and reconnect me, and that it would throw off the audio sync? I'm gonna test the audio sync. Not bad, actually. Give it a... I think an audio sync of like 18 today. So maybe it's, it might be YouTube's problem today. But... that's better. Alright! Anyway. So let's get back into machine learning, shall we? So we were in the middle of a regression analysis. I was going through it pretty quickly because, you know, this is kind of the last point at which we really realistically will cover new material. To preemptively answer your questions for the 10 gazillionth time, the machine learning material is not going to be appearing on the examination. I would recommend doing assignment 10, though, if you haven't already. So, assignment 10 is very good practice with working with two-dimensional lists, which is a thing that you're going to be uncomfortable if you're not comfortable with working with two-dimensional lists. Let's put it that way. So, here is a randomly generated data set split into training and testing data. There we go. If we plot the training data, then we get a graph of it, obviously. And what we want to do is we want to generate a regression analysis on these data points. And for that, we can use Scikitlearn. So sklearn, import linear model, regression is equal to linear model.regression, so we're instantiating the linear regression class. We then have to fix the array as a one-dimensional array in order to do a two-dimensional regression, because they're used to more than that. Details on the following slide. And if you just make a call to regression.fit with the with the data safely ensconced in the method call, then you can get the coefficient and intercept directly from the object. There we go. So we can use the proposed coefficient and intercept to predict the y value of the testing data from its x values. So just to recap the process for this, first you want to obtain your data. Next, divide the data into two sets, the training set and the testing set. We then want to perform linear regression modeling on the training data to get the proposed coefficient and the intercept. We then wish to use the proposed coefficient and intercept to predict the y values in the testing data. So the first half of the data is used to... Aw, the kitten is so sleepy. Hello, sleepy kitten. You're going to have to come on stream now, because you are a sleepy kitten. Come here. I know you don't want to come. That's all right. Here we go. Floop. There. So, the proposed value of the coefficient and the intercept, we're going to see how far the testing data differs from the training data, and then come up with some sort of measure of that. The measure of that we're going to use is the mean squared, or r-squared coefficient. Well, I think we're going to do both, actually. Come on. Don't. There. Well, there we go. Yeah. Yeah, and so, like, we're about halfway through this process. Whack! Pulled my cord. Questions? When will the solution for assignment 9 be released? Well, have the marks gone back for it first? There's a question. Probably at some point after the marks go back. So, so anyway. Yes. So, if you want, so this code, all this is really doing is demonstrating to us that, you know, it's plotting our linear model on our testing data. So we can see that the testing data does actually deviate somewhat, but that's okay. It looks like if we incorporated sinusoidal motion, we'd get a better fit, but, you know. Yeah. So there you go. In order to measure how far the predicted y values are from the real values, we'll use the mean square error, where smaller numbers are better, and the r-squared score, where closer to 1 is better. The mean squared error can be imported, again, from sklearn.metrics. So sklearn.metrics import mean squared error and r-squared score. The mean squared error, you give it your test values and your predicted y values, right? So in order to calculate the difference between the two, you need like an array of the one and an array of the other, and you can just sort of throw them in. Same thing with the r-squared score, and therefore we can print out the results. Easy. You can also perform linear regression with multidimensional data. So not all of the data that you're going to encounter in your lives has only 2 dimensions. Obviously, with 2-dimensional data, you're looking at a y equals cx plus b. In the case of 3-dimensional data, x3 is equal to c1 times x1 plus c2 times x2 plus b. So you can see the pattern here is we just add another another guy here for every additional dimension. Cool. And this is what this would look like with three-dimensional data. Don't worry about seeing the workbook on Avenue because it doesn't exist. But you can see if we have like this plane of data points, we can fit a two-dimensional regression model. It's still a linear regression because it's not like the plane is inflected or anything. But it's, yeah, so a regression model typically will produce an object that is 1 minus the dimensionality of the data set that it's working on. So because you're working with 3D data, you end up with a 2D object which expressed in 3D space, which is, of course, a plane. There you go. Questions? Heh. Okay, so the marks are back. So probably the solutions should be out soon. I would be more concerned, if I were you, with making sure that assignment 10 is done and finished prior to the point at which it needs to be handed in. If you've already done that, then fair enough, but I think that would be a better use of your time. So let's talk about classification. Usually, classification is a type of supervised learning. However, there are unsupervised classifiers that do exist. Normally, we have two or more classes or labels. Think back to our animals example. If we are trying to produce a classification algorithm that will determine whether or not something is a reptile, then we have, in that particular case, two labels. We have reptile and not reptile. If you wanted to, you could expand that to, identify any of the various types of reptiles that exist, or you could even identify, reptiles, amphibians, fish, mammals, all of the major phyla? I think that's phyla? Close to phyla, anyway. No, phylum, it would be phylum chordata. Anyway, so, back to our animal example. Our first column is the animal name, which is, not super useful. Columns 2 through 6 contain the feature vectors, the features, which we then turn into feature vectors. And then column 7 is the classification, reptile or not reptile. We want to come up with a model that predicts the classification based on the features. So, of course, the first thing that we do is transform everything into a feature vector. For our animals, we get the following feature vectors, etc., etc. Again, I'm going to observe that the fact that we're counting each one of the 4 legs here rather than the presence of legs may skew the data, at least, if the data isn't normalized, it would skew the data. So here's our procedure for creating a classification algorithm. First, obtain labeled data. Done. Second, construct feature vectors for the labeled data. Done. Divide the data into two sets, the training set and the testing set. Train a classifier on the training data to develop a model, and use the classifier to predict the labels for the testing data. Next, we wish to measure the accuracy of the predicted data on the testing data, of the predicted label on the testing data. So you can see this is roughly very similar to the procedure for linear regression. We are obtaining the data, we are constructing a training set and a testing set, and we are performing the modeling over the training data, and then we are testing the accuracy of the model using the testing data. By comparing the labels associated with the testing set to the predicted labels that the testing set would have if we applied our models to it. Like, if we have the feature vectors of the things in the testing set and we apply the classification algorithm to them, are the labels that we get the same as the labels that are already in the testing data? So, yes. I'm just going to check for questions. When we finish the course, will the course be removed from Avenue to Learn, or will it remain there? Good question. Quick answer. It will stay up there. You can look backwards into posterity. I actually have the ability to look back a rather long way back. I don't know if I've got anything in here that's like pre-Avenue, but yeah, oh yeah, I do. You can see I have, well, actually that might not be pre-Avenue, but I've got an old graduate course, Computing and Science 725 from 2011 still in there. So, yep, you can still get that stuff. Don't calculate how long I've been in grad school. Don't do it. I forbid you. When the course ends, will we still be able to access your old assignment files? That's a good question. If it's on Jupyter and you want to keep the files, I recommend you download the files sometime during the exam period and keep a local copy of them, because we have to reset the server every semester to accommodate for the new class that's coming in. We keep records of all of your submissions, and we hold on to those, because you have to hold on to, it's actually a rule that you have to hold on to exam submissions in particular for 7 years past the year in which the exam was taken. Same rule is for receipts. You don't have to you don't have to keep receipts past 7 years. After that, you can never, you don't have to worry about having to produce your receipts during an audit. I think. I'm not a tax lawyer, so, but I think that's the rule. I throw out my receipts after 7 years anyway. But yeah, so we'll keep a record of the submissions, so if you don't save your stuff and you want to get access to it at a later point in time, you can hit me up and I'll be able to provide you with your submissions. However, it's just easier for everyone if you don't have to go through me to get them, so I would recommend downloading everything off of Jupyter once this course is finished, if you want to keep your assignments, which you may. So there you go. Good question. Will our McMaster accounts be deactivated once you graduate? Mine wasn't. I don't think so. I think it's kept around, at least for a little while. I'm not really a good person to ask, though, because I was doing my bachelor's degree for a number of years. Then I took a year and a half off, and I was working in industry for a while. Then I came back to grad school, and I've been in grad school ever since. And in the intervening year and a half, I don't believe they deleted my Mac ID or any of the stuff associated with it, although they might have. Certainly, I believe my McMaster email still worked. But, I kept my old student number when I came back, right? 0644772. But, so, preceding 06, which, back in the day, they, the first 2 digits of your student number were the last 2 digits of the year that you joined the post-secondary system. So, my first year in the post-secondary system was 2006. So, yeah, again, don't calculate how old I am. Don't do it. You're forbidden. But yeah, I don't think you guys have to worry about that just yet. But yeah, anyway, so, if you'd like to measure the accuracy of predicted labels on testing data, Basically, and this is actually true for a whole bunch of different types of tests that can exist, there's a difference between, like, there's a disconnect between the test and the truth, right? In theory, you test in the assumption that your test has a higher possibility of returning a positive result in the case where the thing you're testing is positive, and a negative result in the case where the thing you're testing is negative. Like if you're talking about medical tests, they have to meet certain thresholds with regard to returning false positives and false negatives in order for it to be considered a medically valid test, right? So anyway, when you're classifying data, you can get true positives, false positives, false negatives, and true negatives. The accuracy of a test is the total number of true results according to this table divided by the total number of results. So if the accuracy of a test is 90%, that means that 9 out of 10 cases, 9 out of 10 results are either true positives or true negatives. We will use the Natural Language Toolkit for classification of text and of more general data in Python, in Snake language, in Parseltongue. It's installed on Jupyter Hub 2. This is how you get at it if you want it locally. So number one, you obtain the labeled data. We obtain the data from the source. Data should include labels for each data element. So because we're doing a supervised learning process, we know what the outcomes we want are on all of the data, even once we split it up, right? The result, like the labels on the training data, are used to generate the model, and the labels on the testing data are used to test the model. We construct feature vectors for the labeled data. For the Natural Language Toolkit, we need a list. Each element of the list is a tuple containing two things: a dictionary of feature names and values, and a label. So with our animal example, we have our feature vectors. We have self.reptile is our label. So our feature set is, well, anyway, I don't know. This is a lot. I'm gonna skim through the last few slides here, not go into them hugely. But, like, it's better to get the flavor of this stuff, right? So the code on the previous slide is a somewhat organized way of generating the following labeled data for classification. So notice that we've got the feature vectors are expressed as dictionaries, and we don't have to convert our Boolean values to, like, ones and zeros, the way that we were calculating the Minkowski distance earlier, right? And our labeled data is the second element in the tuple. We then split the data in pretty much the same way as we split the linear data. You want to do it according to a random selection, because that avoids having any, or that minimizes the effect of biases that might be positional within the data. And although, you know, you might get a case where you get like 7 in one group and 2 in the other, which wouldn't make a good test. But, like, ordinarily, if you're doing this for real, you're probably talking about thousands, tens of thousands, hundreds of thousands of data sets if you're trying to do anything, you know, for realsies. So, you know, the probability of getting something that skewed is really, really, really low and decreases the larger your data set is. So there are many, many types of classifiers. But in this particular example, we're using what's called a naive Bayes classifier. So Natural Language Toolkit.classify, import naive Bayes classifier. Our training data is all of our features except the last one. And the classifier is nltk.naiveBayesClassifier.train training data. So that the classifier is an object of that class. So basically, in this case, we're using all of the features except the last one, and we're going to see if we can predict the last one. So, once we have run it, we can demonstrate what the most informative features are. So, the most informative features, according to this Bayes classification, are legs, scales, cold-blooded, and egg-laying. These, I think, are things that we can easily say pretty much all or most reptiles have. Although snakes are, yeah. So, we can use the classifier to predict the labels for the testing data. Predictions, we can keep a list of predictions. For t in testing data, predictions.append classifier.classify t at 0. So, we can just take the first element of t, which is the feature vector, feed the feature vector in, ask the classifier to classify it, and then we can print our predictions. We can then measure the accuracy of it using the classifier that was generated and our testing data wholesale. So there you go. Questions? None. Sentiment analysis. So, a special type of classification problem focuses on the identifying the sentiment in a piece of text. So, does the text represent a positive or negative statement? Is it happy or sad? Is it angry? Is it, well, pick your emotion, basically. The basic approach to this is that you take all of the words in the English language and you associate them with a certain score based on how, you assign each of these words a score according to all of these emotional indications. So if somebody uses the word tragedy, for instance, tragedy would probably be associated with sad and possibly angry, maybe. People usually say, that's a tragedy, when they're angry, sometimes. Again, this sort of is very loose and cultural, but it's a thing that, people are now using. So a certain amount of research going on around this type of stuff right now. So our machine learning approach is to label pieces of text as having a particular sentiment, and then using classification to predict the sentiment. So, again, the process is obtain the labeled data, construct the feature vectors. In this case, we'll use natural language processing to construct feature vectors, divide the data into datasets, training data and testing data, train a classifier, use the classifier to predict the labels for the testing data, and then measure the accuracy. So, our goal is to transform natural language text into a form that's more effectively processed. We haven't really talked about parsing very much, but the first thing you do in parsing is you tokenize. Taking a sentence and splitting it up into words is tokenizing. You can do the same thing to programming code, but at this point we're talking about, natural language. Natural language is what programmers call language. Like the languages that humans use, as opposed to the languages that computers use. Computer scientists and software engineers refer to those as natural language. But yeah. So if you've ever done the split on space operation in Python, that's the poor man's tokenizer. So, once the sentence has been split into words, we can examine each of the individual tokens, or words, in the passage of text, and also tag them with what their grammatical role is. So, there's not much point in associating sentiment with words like the, in, etc. These sorts of, prepositions are usually not, they don't carry much in the way of sentimental content, but they are important for the grammatical construction of a sentence. So, our goal is to transform, So the other thing that we want to do is we want to do what's called stemming. So if you if you consider the way that English is constructed, take for example the word happy. You can have words based on the word happy, like happier, happiest, happiness. Um, you know, if you have a word like run, you can have run, ran, runs, running, etc., etc. So you want to normalize for all of these cases and modifications because we're really just interested in the number of instances of the use of the root word, which is happy in this case. And we also, again, want to outright remove all of these words that don't convey much meaning in terms of sentiment. We then construct the feature vectors using natural language processing. So the process as described, construct a list of all processed tokens presented in the sample, and for each sample, construct feature vectors indicating the number of times each word is present in the sample. Yes. So if someone is saying, if somebody tweets something, for instance, happy, 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 it's probably that they're more happy than if they had just said happy, 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 right? Of course, to a mathematician, that all makes sense. The sad truth about these algorithms is, it's impossible for them to capture the full nuance of human language communication, but they do with what they can. So you can perform automated sentiment analysis using Vader. Vader is a sentiment analysis tool built into the Natural Language Toolkit. It's already trained to classify passages of English text on a positive or negative sentiment. So, if you have a sentence, if you're happy and you know it, clap your hands, and you instantiate the Vader sentiment analyzer, and then you can print the polarity scores of that text just by a simple function invocation. So, negative, it's not a negative sentence. It is a 0.7 neutral sentiment. It is a 0.3 approximately positive sentiment, and its compound sentiment value is about 0.57. So it's actually, if you're happy and you know it, clap your hands, is primarily a neutral statement. But yeah, kind of similar to that Pharrell Williams song. The song Happy is basically a rewrite if you're happy and it's a rewrite of if you're happy and you know it, clap your hands. Like, it's amazing to me that somebody was able to top the charts for so long with a reimagining of if you're happy and you know it, clap your hands. What's next? Somebody hits the charts big time with a modern remix of Ring Around the Rosie. Like, seriously, people. Anyway. Yep, okay, so that's all nonsense. That shouldn't be in there. So yeah, that's the course. Thank you very much for paying attention to the course. That's all of the content. So I didn't cheap out. You guys got all of the machine learning lecture, although we did go through it a little quickly. Does the word exam have a sad or angry association? Good question. Let's see if we can do that. That'll be fun. Boop. Oh, I've got it up already. That's fun. All right, let's see if we can do it. Import and natural language. I might not have natural language toolkit, but nope, don't have it. How can I get it though? Doop 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 doop. So sudo pip3 install numpy scipy scikitlearn. Boop. And installing. This is how easy Linux is, guys. Bammo! Alright. So I'm just going to quit this because you'll probably have to reload it, right? Python 3. Import. Let's try that again, shall we? Import nltk.sentiment.vader. Module not found. No module nl. What? Really? Huh. Still no, huh? Oh well. Well, maybe I'd have to download Anaconda or something. I didn't understand how to create an SQL in Python, so can you quickly go over that? Tomorrow! Kate, take that and save it for the review session. And it's not create an SQL, it's create a database. SQL is the language for accessing the database. pip3 install nltk? Sure, let's try it. pip3 install nltk. Probably. Collecting nltk. Oh, this is doing stuff. Bloop, bloop, bloop. Alright, let's try it. Python 3. Import nltk.sentiment.vader. Runtime error. Module compatible. Weird. Maybe I have to do that with numpy as well. pip3 install numpy. Numpy, no. Is this goodbye forever, or will we see each other in other courses? Well, at the moment, all I teach is 1MD3 and 2MP3. I'm not going to be teaching anything other than 1MD3 next semester. I'm actually... I'm going to be, I think, in the future pursuing some... I've got a really good career opportunity that has come out in Mohawk College. They're starting up a new program in video game design, and I used to back a few years ago I used to run a video game development club at Mohawk College, and some people from the animation department have been pushing for this program to exist, and they've approached me and asked me if I wanted to be a coordinator for that program. So that's not something I can pass up, you know. So I want to get my degree and get out of Dodge, but no, I think that it's kind of sad to say, but I don't think you'll be seeing me again. I don't think we'll have any more courses together unless something changes. But and who knows, you know. The world's a complicated and strange place. And, you know, yeah, but we'll see. We'll see how it goes. But yeah, this has been fun. I've really enjoyed teaching this class. I've really enjoyed you guys. Despite the fact that one of you at one point completely broke the autograder. But yeah, no, this has been fun. Where can we find assignment 4 and 5 solution? They should be posted somewhere. I think they've been posting them to Piazza, haven't they? Yeah. Well, I mean, you know, it's actually not uncommon for people to do a college diploma after their bachelor's degree. But, yeah. But yeah, it's I'm really excited about the opportunity. The program was approved. This is kind of a little bit of insider information, but I feel we can I can share this information because it's actually been approved by the Board of Governors. We're working towards a 2022 rollout of the program at this point here, and you know I'll see if I can get those centrally posted for you, Tess. Um, but yeah, it's really going to be cool. It's interesting because the program is like a design program, so it's focusing a bit more on it seems like a really well-rounded program between the arts and the programming side of it. Like there are lots of courses on sound design and 2D and 3D art, as well as game theory. But like I'm kind of the guy when it comes to the programming side of things. So I've got Tess, if you wouldn't mind sending me an email about that, just to remind me, that would be appreciated. If you I'll basically have the programming stream of it to design with only ministry guidance. So I'm going to have to pick some good textbooks. But we're going to be doing C++ because that's what the Unreal Engine uses. But yeah, I guess I'm not directly trying to drum up some. I'm not trying to poach people from this program yet. But if you've finished your comp sci degrees here at McMaster and you feel, oh man, wouldn't it just be great to have a college diploma to round this out with? Well, your old friend Mr. Moore, by that time Dr. Moore, might have a program for you at Mohawk College. What do I think some interesting games are from a game design standpoint? That's a good question. One that I played recently that I think is the story is a little unimaginative, but it ticks all of the boxes with respect to good game design, like mechanical game design, is Panzer Paladin. So I recommend checking that one out. Some good games. Well, I mean, you can always recommend the masters, right? Mario 3, Super Mario 64. I think Majora's Mask is brilliant. But maybe you're more interested in indie games. Obviously, Dark Souls is extremely well designed. I've been playing a game recently called Helix 2. I think it's pronounced Helix, but it's spelt with a Y. I'll type the name into the chat. It's extremely bizarre. It's like a it's basically an RPG Maker game, which normally the quality on those games in terms of the programming is complete shit, because the people who make RPG Maker games are not programmers, typically speaking, and you can tell that this guy who made this game, not a programmer at all, but it's got this really strange aesthetic to it. It's basically all of the in-game graphics are clay models or clay textures that have been overlaid 3D scans of clay objects, and it's like modeling clay, and it's very it's got a very sort of it's almost like Dadaism, but in a video game. It's very strange, very out there, and I love it. But it's hell to play because they expect you to do a lot of platforming. It's really not an engine that's designed for platforming. But anyway, what do I think of Universal Paperclips? I've never heard of it. Let me see this. Oop. I hope that doesn't cut my stream out. Jeez. I was playing Dragon Quest on my phone. Universal Paperclips. Oh, I think I've seen this. Yeah. Yeah, that's cool. I've never tried it, so I can't give you an educated opinion, but yeah, maybe I'll give it a bash. Any thoughts on Cyberpunk 2077? It'll do well. I generally speaking, what is it? CD Projekt Red, right? You know, I think they've still got enough gas left in the tank from the goodwill generated from the gaming population over Witcher 3, which I never actually played Witcher 3. I actually don't tend to play the really big AAA games, particularly the ones that are sort of PlayStation and Xbox centric. I'm really more of like my interest is more in like snacky sized indie games because I'm cheap as hell. But yeah, I mean it'll do well regardless as to whether it's any good or not. I think Cyberpunk as an aesthetic is making a comeback, which is interesting. I kind of feel like it captures the zeitgeist a little bit because like everybody feels like they're living in a dystopia right now. So yes, comes out on Thursday. Thursday's the exam, so if you buy Cyberpunk 2077, wait till Friday, please. Or wait till you're finished with the exam. But yeah. Oh, those cruel bastards. They're releasing it right before the exam period, eh? Yeah, no, to be honest with you, I haven't really... it's only been sort of in my headspace with respect to the... with the meme value. I should get Spelunky 2 and play it with you. Open TTD. That's a tower defense game? Stream, please? Oh, you want me to stream games? I don't know, man. I suppose I could do that. I don't know. I'm really busy. I don't consider myself a streamer, you know? Which is weird because I've been doing all of these lecture streams, but like, I don't know. You know, if I was gonna do a game stream, I don't know. It's tricky because you kind of oh, you found the solutions. Good. It's tricky because like people legitimately get like their accounts taken down for that sort of thing. Maybe if I did a second channel and then did some game streams in it, but yeah, I don't know. Well, anyway. Universal Paperclips was made by a game design professor who wanted to prove to himself that his students that he could actually make games. Yeah. This is yep. I mean, yeah. Yeah, I mean it is important to have some game design chops. I'm hoping at some point over the Christmas break I'll have some time to put the final polish on a game that I'd like to release on Steam sometime in the new year, called Hexy Hashy, which is it's an adaptation of Hashi, which is a puzzle by the Sudoku people, to hexagonal grids, which actually completely changes it because it's regularly on a rectangular grid, and it completely opens up the strategy when you have 2 more possibilities per node. We'll see how it goes. I think it'll do better than my pinball game for sure, but you know, because it's a much better game than the pinball game. The pinball game is, you know, realistically a bit shite, but you know, that's fine. It was my first product. Open TTD. I'm assuming that's a tower defense game. Oh. No. Oh, Transport Tycoon. Oh, yeah. Guessing you don't like to play 80-hour JRPGs. Actually, no, I'm a big Dragon Quest fan. No, I actually do like to have like a big ass JRPG on the go most of the time. At the moment, it's Dragon Quest XI: Echoes of the Elusive Age, which is, you know, I got the edition on the Switch. I rather like it. I kind of like those. I'm also, I don't know. I liked the original Xenoblade, but then like the Xenoblade 2 was way too fan servicey. I used to like Fire Emblem, and then they fan serviced it up, and now it's like I feel dirty playing it. It's gross. Like, why can't I just have a good JRPG without the fan service? Yeah, Dragon Quest is like the music alone, But yeah. Shit! I've got the other class. Oh, damn. Okay, I gotta end the stream. Sorry, guys.